Okay, we're going to do a little graphing inequalities short lesson. This is 2.8 Algebra 2. First thing we're going to do is take our equation 2x minus 3y is less than 9. Oh, make sure you got your packet open to the slides for this section, obviously. We could graph it using the standard form stuff, but you got to watch out for negative signs, and because we're going to have a dotted or a solid, and we're going to shade above or shade below. You'd rather solve for y first. It's going to make your life easier. So I move some stuff around here. Get myself 3y, negative 3y, very important. It's less than negative 2x plus 9. Divide everything by negative 3. If I divide by a negative, I must remember to change the sign from less than to greater than. I end up with y is greater than 2/3 x minus 3. Graph the line, go down to negative 3, a point there. Apply the slope of 2/3 up to right 3. You can do it again if you so choose, up to right 3. And now I'm going to make a line, but my line is actually going to be a dotted line because I want to know where the y values are greater than this line. It's not or equal to, so I'm going to have a dotted. So we can put in a dotted, put in some arrows, and select this guy, select this guy, and we can go, let's go purple, sure, see what happens. Oh, that's way too light. I gotta turn that up. Let's try that again. There we go. Dotted line, shading, where? I want to know where the y, where the y values are going to be greater than. Why am I in all of this now? There we go. I want my y values to be greater than. So you're reading it as y's are greater than. Where do the y values get bigger? The y values get bigger up here. I'm going to shade all of this. This is the set of all points that will satisfy the given equation. It says boundary check. I don't think we need to do a boundary check. That's going to be the dotted line. We should be able to recognize that it's dotted right here. Dotted will be greater than or less than. That's not less than. Greater than or less than. That's dotted. Solid will be greater than or equal to, less than or equal to. Solid. Then we solve for y and we say, where are the y's greater than? It's above. Test point. I always use the origin whenever possible. 0, 0. 0, 0 should satisfy the equation. Is 0 minus 0 less than 9? Is 0 less than 9? The answer is yes. That's a test point. The biggest thing that the test point does is make sure that you've shaded in the correct spot. If you did not recognize right here where we divided by a negative that you needed to flip the sign, that's where the mistake would show up. You would have shaded on the wrong side. Try another one. Y minus 2 is greater than or equal to 2 times x plus 3. Now this one's in point slope form. You can run it straight out of point slope form since I know I don't have anything being multiplied by the y. It's going through the point negative 3, positive 2, and has a slope of 2. It has a solid line. It has a shade above. I can already tell. Again, there's nothing connected to the y there, so I can do solid and above. We could read this one right out of the chute. So I could go negative 3, positive 2, and then I could apply the slope of up 2, right 1, up 2, right 1, up 2, right 1. And then I can draw a line. Let's use the nice lines here. I want this one to be solid, so I'm going to go like so. Beauty. That's a little thicker than we probably need, but it gets the job done, doesn't it? And then it says shade above. Again, where do the Y's get bigger? The Y's are going to get bigger up here, so we're going to be above it. We're going to kind of be the upper left portion of it. Maybe we should grab a highlighter. Do this. Oh, now we're cooking with gas. All right, look at that. Pretty. I'm getting better at this, you know. Things are going well. I'm doing all right. I'm getting good grades. My future's so bright. You know the rest. Pick a point. Should the origin work? The answer is no. The origin should fail because it's not in the shaded region. In this case, the points on the line are part of the system. The set of all ordered pairs that are a solution. So if we're going to say check the origin, check, maybe 1, 0 minus 2 greater than or equal to 2 times 0 plus 3. Is negative 2 greater than or equal to 6? Heck no. 0, 0 doesn't work, so we're not surprised because it's not in the shaded region. These points will work up here because they are in the shaded region. Good times, good times. Which graph is the graph of 2x plus 5y is greater than 10? Notice they have the same boundary line graphed, but we got to check to see whether or not we're going to have it shading above, shading below, dotted, or solid. Notice I can already tell it's going to be a dotted line. So this one is not dotted. This one is not dotted. Those two are dotted. I got to figure out if I'll shade above or shade below. You can see it's a positive. Pretty sure it's going to be above. Let's solve anyway. 5y great, not or equal to 5y greater than negative 2x plus 10, y greater than negative 2/5 x plus 2. I divided by a positive. Shading above, got to be a, huh? Got to be. This would be less than. And those ones were solid lines. Hopefully this isn't mind-blowing material for you. Ooh, an absolute value. Remember when we talked about the other day, we talked about absolute values, and we had something like this, and the H and K moved it left, right. Got to remember this. Left, right, and the K moved it up, down. So this one's going to go 2 units down. Put a dot there. Greater than or equal to, so it'll be solid. Has a slope basically of 1 going this way and negative 1 going this way, because remember it's a V. Absolute values are the V's. Kind of a straight line. Shading above, where are the Y's greater than? So you're going to be in. So for the absolute values, you're either like inside the V or outside the V. Couple of these on your homework where they move you around a little bit. There you go. The origin should work. Is 0 greater than or equal to the absolute value of 0 minus 2? Is 0 greater than or equal to negative 2? You're darn right it is, and it works. It's right there. So we moved our 2 down. Again, the boundary line is solid because it's or equal to. That means the points on the boundary are good to go. They're part of the solution. Check one if you want. If you want to check 2, 0, check it. Check it. 2, 0. 2, 0. 0. Is 0 greater? Is 0? A little sketchy here. Pad. Is 0 greater than? Is 0 greater than or equal to 0 minus 2? 0 is greater than 2. So we are good. Again, we're just reading the graph. Less than, so it's got to be dotted. That means it's B or C. Y is less than, so we are Y is less than. dotted and shading below, it's going to be B. B is going to be the correct answer. B is correct. Write the three other inequalities. A looks like it's shading below and solid. Y is less than or equal to the absolute value of x plus 3. C is dotted and shade above, so its y is greater than. And D is solid, so it's greater than or equal to. That's it. So graph paper. Make sure you get graph paper for this lesson. You should be able to finish all of the homework now for lesson 2.8. Homework check will be next class period, along with the review and preparation for the test. Have a wonderful day.